If an object that is one solid piece of single material floats with 60% of its total volume submerged, what is the density of the object? Now, we're talking about a floating object here, and we're talking about density, and we're given information about the volume that is submerged, which is really the volume displaced. So on the key concepts page, we had a formula that said the fractional volume displaced, in other words, the ratio of the volume displaced to the volume of the object, is equal to the ratio of the density of the floating object to the density of the fluid it is floating in. So I think that was the equation on the key concepts page. I'd like to arrive, you could use this formula to answer this question, definitely, but I'd like to look at it maybe from more basic concepts and just show that you really don't need these other two formulas. I mean, they're kind of time savers sometimes, but you can start with basic concepts of buoyancy, such as Archimedes' principle, which states that the weight of water, which really is kind of the buoyant force, is the weight of water displaced. So the expression we had for that is that the density of the fluid times g times volume displaced, in other words, this is the buoyant force, is equal to the weight of the object itself. So if we're talking about whatever this object is, some unknown object here, that would be the mass of that object times g. To actually get a numerical answer for this question, I'm going to assume that we're talking about it floating in ordinary water, even though it didn't say that. But I mean, I think if you imagine saying this to a child and you said, the object floats, would they imagine anything other than water, right? Maybe well-educated adults who are majoring in science discipline might say, well, you didn't say what fluid, but we'll go with water, right? So looking at this, I can take the right side here, and the mass of the object would be equal to the density of the object times the volume of the object times g. And on this side, maybe I could rearrange things so I'd have volume of fluid times volume displaced times g, and then it becomes convenient to knock away those g's. And at this point, I think we actually have a formula here that is algebraically equivalent to what was on the key concepts page. So that kind of establishes that connection. But since we're asked for the density of the object, I'm going to go ahead and isolate rho object by dividing both sides by the volume of the object. So then we get rho of the fluid times volume displaced divided by volume of the object, which is equivalent to just saying that ratio of volumes multiplied by the density of the fluid. This whole ratio, since we're told that 60% of the total volume is submerged, I think it's fair to say that that means the ratio of the volume displaced to the object's volume would be equal to 0.6, reflecting that 60%, and then multiply that by the density of water of 1,000 kilograms per meter cubed, and that should give me the density of the object, which will be 600 kilograms per meter cubed. So we can go ahead and check that answer, and it looks like it worked.